share. Okie dokie. So tonight, by the way, congratulations for making it all the way through to week 8. I think that's spectacular. This is not an easy class for most people, so I think this is time to just congratulate you. So this week, we're kind of capping off the class with an introduction to Python classes. Now, a class in Python is the definition of both variables and methods that are grouped together for a specific thing. And they show a stove on here. The stove is a thing, or the design for the stove would be a class, and the stove that you would go to the appliance store and buy would be an object. An object is an instance of a class. And I know that kind of seems maybe a little esoteric right now, but we'll kind of get into that more as we go through this. And what this really allows you to do is give yourself to give yourself a representation of whatever it is you're talking about that is bigger than just a variable or just a function. So you can create an object. That object is an instance of a class. That's just what it's called. And you can assign that to a variable. So you can take all kinds of data and all kinds of methods together and pass them around. And it's powerful because you can have multiple objects. I could have a Maytag refrigerator and a Samsung refrigerator and an LG refrigerator. They're all refrigerators. They all have doors, and they all have cooling units, and they all have freezers in them, but they're different. They're made by different manufacturers. They may have different sizes. Some may have, ice machines in them. Some may not have ice machines in them, but they're all refrigerators. So the Maytag or the Samsung or the LG refrigerators are what we would call objects. The fact that it's a refrigerator that has doors and some height, width, and depth, and may or may not have an ice maker, is the class, because it's the definition. It defines it. It's like a blueprint. So, and there is specific syntax to classes. Now, they're talking about grouping data, and that's what you're doing with a class. You're grouping lots of things. So, in Python, you have this new keyword called class, and that's just what it does. It defines a class. The class, and by the way, the class is our gateway to object-oriented programming. When you talk about a language like Java, Java is completely object-oriented. Everything lives inside of a class. When you talk about a language like Python, you can have classes, but you don't have to have classes. Everything we've done up till here is procedural. So it does not have to have a class. Your variables live separately from your methods. But now we're combining things and we are getting into object-oriented programming. Object-oriented programming is the way a lot of programming is done these days. So it's important to understand the concepts. So the word class in Python is a key word. It tells Python that anything coming after it is the name of the class. And just like a variable has a name or a method has a name, a class has a name. And that class name has to be unique, and it has to follow specific constructs. Like it can't start with an underscore. It's basically very close to what the same constructs you can use for a variable. The word class is always left justified, and everything underneath a class that's part of that class is indented to the right at least 1. So down here, they have a class called time. So I'm going to create a class in Pycharm, and I'm going to call it square. So I'm going to create a file called square, and I'm going to create a configuration for it. Just give me a second. And we're just going to create a really simple class called square. Let me add an interpreter. Oops, there we go. So I'm going to define this thing called square, and I'm going to say class, class square colon. Now the colon, just like when we have a definition for a method that ends in a colon, we have a definition for a class, and we have to tell Python that we're done creating the class name by giving it a colon. And so for the square, I'm going to have length. I'm just going to set it to 0. Width, I'm going to set it to 0. Now I'm going to do something. And I'll explain what I'm doing in a minute. Oops. And then we'll go through this. I'm just getting it out of my head for a second. Okay, so I just created this really simple class. I have a class, its name is square, and probably should have been called rectangle, but it's going to be called square for right now. So I have two variables. I have length and I have width. Those two variables only exist inside this class, and we'll only be able to get to them when we create an object of this class. So those are just variables. They sit there. They are about a square. Square has to have a length and it has to have a width. And then I've done this other thing here, and it's kind of different because we start off with these underscores. We have the word init and then 2 underscores, and now we have this word self. So what is all of this? Def means I'm defining a method. So we know that. We know that at this point I'm making a function. So the underscore init function is a special function in a class. It is called a constructor. And when you are creating an object from a class, you are constructing it. And if you want to pass data in to the object that you're creating when you're creating it, you have to define this method called underscore init underscore. And then you can pass information. Now, there are a couple things that, there's another thing that's new here called self. The concept of self for an object is that it's myself, okay? For each object that you create for any given class, it has the knowledge of the fact that it has data and methods. And the data that it has is self data. It can't get to the data of any other object. It can only get to the data or the variables for itself. And but you have to, even though all objects know that, in Python, any function that you are using on a class, on an object that has to have knowledge of the fact that it's an object has to have self. It's just a construct. Basically, if you're defining a class, all your methods will most likely have self as the very first argument. Then you can pass in other data. Now in this case, I'm passing in L for length and W for width because I want a length and a width. And then I take length and width, which I defined up here as variables, and I'm going to set them, that's all I'm going to do, is set them to L and W. And so that's all. That's what the constructor does. That's its whole job in life, is to initialize the class and do anything that initialize an object and do anything that that object has to do before I get my reference to it. And then I have created a function called area. Now, area doesn't have any underscores in it. It is just a function named area. And I have self and, I didn't get my syntax right because I've been writing in another programming language today. Okay. So that's why there were underscores. So let me finish explaining area and I'll go back and explain what I did. So here, all I'm going to do is multiply length times width. So I have to give, and that's what the self is for, and I apologize for not doing that right off the bat. So I have to give whatever I'm going to calculate. Well, I'm going to calculate the length times the width because that's how I calculate an area. And I have to tell it where I'm getting that information from. And the self that I'm using tells me to get it from the object that I will create. And here as well, I had self.length and self.width rather than length and width. Self says use these. Otherwise, it would have just had a length and a width here and nothing would have happened. And I'll show you why that would have been an error in a minute. So I have this thing called square. So what do I do with it? Well, what I do with it, well, actually, I'm not going to create another file. I'm going to go outside the class. So right now, whoops. Okay. There we go. So right now, and I'm just going to do this. Just so it's easier for people to know that it's the end of the class definition. So now what I'm going to do is I'm going to create an object of class square. So I'm going to say my square equals, and I'm going to pass it in 5, 5. Okay? So what did I do? And I'm going to show you in a second in the debugger, exactly what happens in Python. My apologies. There we go. So what I've done is I've taken this thing called square that I've defined up here, and I've passed in this 5, 5. I've passed in 2 integer values. So what's going to happen is that I'm going to end up in this function, underscore, underscore, init, and it's going to assign a length of 5 and a width of 5. And then I can call area. And it's going to print the area of my square. So let's take a quick look and see what happens in the debugger, because I think the debugger is a good tool to show you what's going on. So I'm right now in the debugger, and you'll see that the first place I stopped is line 15. All of this is just a definition at this point. Python does not know what to do. It says, okay, I've got a class, but that's just a definition. So I'm just going to read in all this stuff, and I'm not going to do anything with it. It won't do anything with all of this information I gave it until I get down to here, where I'm actually going to say, create an object of type square. So I'm going to step into this, and you will see that I am here. Okay, I am now in this def underscore underscore init underscore underscore as the constructor. You will also see up here it says self main underscore underscore main underscore underscore dot square object at. This is a memory address. That 0x7 blah 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 is a hexadecimal value, and it is a memory address in the running Python program that says I am creating something unique. It is unique from all other instances of square and anything else in Python. And I'm going to take up so much space in the computer, and I'm going to set the first, oops, my bad, I'm sorry. No, so I'm just going to step over this. Okay, there it comes back. The first value is 5 and the second value is 5. So what am I doing here? Well, if I look down here, I have this self square object, and I've just set length equal to 5 under self. And under self means I have set it in an object. And now I'm going to step over it again, and I will have done the same for width. And now I'm back here at my square again. And when I step over my square, you will see that I have defined my square. It's of type square. That's how you read this. My square is of type square, and this is its unique address in Python with a length and a width of 5. So now I'm going to step over one more time, and you'll see I say my square dot area. My square is how I reference the square class. So my square is an object of type square, and because I have created the object in line 15, I can then use that object to calculate area. So if I step over, my console says 25. So now I'm going to create another function, def print square self. And I'm going to say print say length is, width is, area is. Now, you'll see I just did a self dot, and it gives me all of this stuff. But you'll see that length is there, width is there, and area is there. And that's because Pycharm is smart enough to know I've created a class, and those things are about that class. So, whoops, that was wrong. I didn't want area. That'll be the third one. So self.length dot width and self.area. So now instead of print my square, I can say And so I'm going to run this, and you will see that it says length is 5, width is 5, and area is 25. That's all fine and good, but why did I go to all that trouble to define it if I could have just done that? Well, because maybe I want more than one square. So I'm now going to define my rectangle. My rect is a square of 10, 2. And when I run it, whoops, I didn't do that way. And then it's going to be my rect dot print square. So I now have two. I have my square and my rect. So let's say I want 2 is square of 11, 22, just as a number, and then rect2 dot print square. So now I have a third object of class square. And while this is a very simple class and it's a very simple example, you can see where if we have a lot of complex calculations or complex data manipulation that we're doing, it is often very smart to put it into a class, because that way you can have multiple instances of that class created as objects and do that manipulation separately. I can use the example of students in a class. I have 25 students in a class. I don't want to have to necessarily use a procedural set of programming constructs to deal with all 25 students in that class. It's really great if I can define in Python a student class, and that student class will have bunches of stuff in it and do all my calculations, and I can just say student.calculate, and it will calculate a grade or something along those lines. So that's how you define a class. That's how you define a constructor. Let's see. Let's keep going. Instance methods. We were just talking about instance methods. Area is an instance method. And it's just like defining any other method that we have done it in Python, with the exception that you do a self. Because a self says, I am getting data from the object, from within the object. Oh, and let me go back and show you what I had done originally was wrong. I had originally not put the self.length. So I'm going to take this off right here and that off. Those are the only changes I made, and I'm going to run this. And all of a sudden, everything is 0, 0, 0. Why is everything 0, 0, 0? Well, because this is a variable in the method scope. It is not a variable in the class scope. So this length only exists for this. That's all the length exists for. After that, that length goes away. This length is not this length. This length only becomes this length when I do this. And when I do this. So now, with those two changes, I run it, and I get the answers that I'm expecting again. So that's a really, really big pitfall that a lot of students fall into in the beginning, because they're not aware of what self really does. And that's what self does. The same as if I have area here, So that's what happens. The only thing I have done, let me just getting rid of all these cells. Okay? And actually it's not going to work anyway. But, so I get a problem. You know, print length is error. Area takes positional arguments, but none was given. And that's because it doesn't know what to do at this point. So Python has said, wait a minute, I don't know what to do. So, and that's because I am attempting to use a class method that is expecting the fact that it's going to be an instance and it's not. So self made that work because I'm inside the class. Or actually I'm inside the object. Now the other thing you can do, and it's just to mention it, you can also pass in data to a method. You can pass in data to a class method as well. You can assign parameters. Sorry, I'm not finding my words well tonight. So let's go down and we'll do, are there any challenges anybody wants to do specifically tonight, or any labs anyone wants to look at specifically? If not, I'll just pick some. Okay. So this is just challenge 831, and it says define the method object IncNumKids for person info. IncNumKids increments the number data numKids. So let's look at that. Okay, so all they want us to do is new baby, kids now 1. Oh, okay, they just want us to up the number of kids. So all we have to do for this one is just define an instance method. So this is challenge 831. Okay, so all they want us to do is def self. NumKids equals self. NumKids plus 1. So let's see what happens when I run it. Okay, so that's what they wanted us to do. So that's all they wanted us to do here, was define an instance method. So that's what we did. So class and instance object types. What did I just do? Okay. So that's what we were talking about in area, that I can have multiple objects of the same type of class, of the same class, as many as I want. So in this case, like I was talking about students a minute ago, they're talking about marathon runners. So they have, let's say they have 100 people in a marathon. And so they're going to define 100 marathon runner objects, one for each runner, and use that to keep track of the runner's pace and the runner's time and whatever they keep track of for runners. Let's see. So this is just an example for a seat reservation system. and they have, basically you have your seat, you're going to have the initialization, and by the way, you can initialize without actually passing things in. Somebody who's going to reserve a seat, you're going to make the seat empty, you're going to ask if the seat is empty, and you're going to print the seat. And up until line 21, up and through line 21, everything up till from 1 to 21 is in the class. After that, everything's outside of the class. You can see these defs are left justified, and that means it's outside of the class, so it's not part of that class definition. And then here they're just saying make seat empty, print seats, find available seats, and then you've got this little while loop. It's a control loop, just like your game loop. And basically what you're doing is you're assigning seats and making seats empty, and so, you know, you can enter your commands, and that's what this example is about. We've talked about constructors, the underscore, underscore, init, underscore, underscore, and it's special. You can't name any other method underscore, underscore, init, underscore, underscore. It always has to start with self, and then you can have some number of arguments that are going to be passed in. Now, just like any other function, you can have a default value. So let's say for square, I want a minimum length of 2 and a minimum width of 2, okay? And that is there as a default. So if I don't pass something in, if I just say square and then dot print square, I'm going to get, now you'll see that there is no problem here. And if I run square again with that new object, you'll see that I get a 2, 2, it's an area of 4. And that's because I put in default values. So just like in functions I could assign default values, I can assign default values in the constructor. So that means that I don't have to pass in a variable. Or sorry, pass in a value. My bad. Okay. Interfaces. Now, an interface is it's a definition for a class. It consists of method calls the programmer wants to use to create, modify, and access a class instance. And it doesn't usually contain data. It just contains the methods. I don't use interfaces in Python. I use interfaces all the time in Java, but I don't use them in Python because I just don't find them as useful. And you don't really need to worry about them for this class. In fact, I don't think I know anybody who uses interfaces in Python. They exist. It's important to know they exist, and the concept of an abstract data type exists in Python, but I don't know that it's not something I use. Let me just put it that way. So class customization. You can do lots of class customization. So in this example, what they're doing is they're basically saying underscore underscore stir is a special method that you can define in a class that will return a string value for the class. So in this case, we have, name, price, and min age. But sometimes I want to just print it, but if I just print a square, let me show you what I'm talking about. If I just print square, let me get rid of these for a second, just to make it simpler. Oops. So if I just, I'll get rid of this. If I just print square, I'll show you what's going to happen. This is what you're going to get if I print square. If I say, print my square. My bad. If I print an object of type class square, this is what I'm going to get. That doesn't mean anything to me. All it means is that I have an object of type square. That's all it means. But let's say I don't want to constantly call print underscore square every time I want to print the square. So I can do something different. I can define an underscore underscore stir underscore underscore method. And it's going to return this. That's what it's going to do. So now let's see what happens when I print my square. Lo and behold, that's what I get. I get length is 5, width is 5, and area is 25. So I have reduced the complexity of my code and the ease of reading my code by having this particular function in there. It's a special function. It tells Python to convert to when it's being asked to automatically convert an object of type square to a string, use this method. That's what it's telling Python. So if I go down here and I change all these, the same thing will happen. So let me go here, and you'll notice that print square doesn't exist anymore, but instead of this, I can say print myRect and print rect2, and then print empty square. And if I run it, I get everything that I'm expecting to get. Now, it's great to be able to change that to a string, but there are all kinds of other ones that you can do in Python, okay? So underscore underscore stir underscore underscore isn't the only one. The other type of customization you can do is what they call operator overloading. So let's say if I want to know if one class, if two objects in the same class, if one of them is less than the other, or one of them is greater than the other, or one of them is equal to the other. Well, I can, what they call, overload the operators. So just like I could say, hey Python, if you're trying to automatically make this object a string, use the underscore underscore stir underscore underscore class. You can do the same thing for less than, for greater than, and for equal by using some more special definitions. Underscore underscore LT underscore 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 GT underscore 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 underscore, I think it's EQ underscore underscore. They're all called operator overloading. And let me show you what we do. So I'm going to go back to my square, and I'm going to define, and by the way, you'll see in Pycharm when I do an underscore underscore, I get all of these different things. So I'm going to see if two squares are equal. And you'll see I have a self and an other. So self is the object that is to the left of the decimal point before you say equal, equal. And the object to the right is other. So I'll show you that in just a second. So I'm going to say if self dot length is the same as other dot length, and self dot width is the same as other dot width, then I'm going to return true. Otherwise, I'm going to return false. So now, if I say, let's say I now have two rectangles, and I'll just do it down here, and I'm going to say oops, my bad. So let's see what happens when I get to this line of code. Because what's going to happen is I'm going to end up in here. So I'm going to debug, and I'm going to continue because I don't need to be on that line. So that's myself. That's the, okay. So now I'm where I want to be. And it says if my rect is the same as rect2, print match, else print too bad. So I'm going to just step over, and lo and behold, I make it into this underscore underscore EQ underscore underscore method. Now, let me go back and show you what I did. I'm here, and I didn't use a method. I said equal equal, and with equal equal, I ended up here, and that's because I overloaded the double equal operator for this class. For objects of this type, they will always go in, when you use the equal equal sign, they will always go in to this method. And then I can say, well, is self.length the same as other.length? And is self.width the same as other.width? Now you'll notice I'm using equal equal in here. And that's okay because length and width are integers. You cannot overload an equal equal for an integer. You can only overload it for a class type. So I'm going to step over, I'm going to return false, and I'm going to print too bad. So that is operator overloading. Oops, I don't need to be there. Keep going. And you can do that with less than, greater than, all of those. These are just some of the comparison methods. Less than or equal, greater than or equal, equal, and not equal. Very powerful, very useful, and it reduces code complexity. Everybody knows what a double equal does. Are they the same? That's just an example of the rich comparison. We're getting close to 10. So this is just the car value class, and this is just an example. This is the lab. So let's just take a look at this lab really quick. Complete the car class by creating an attribute purchase price of type int and a method printinfo that outputs the car's information. Okay? So they've got already this car class. They've got an constructor. They've got calculating the value. But what they want to do is they want to define print info. So if you look at this, and if we look at an earlier version of it, I had defined print square. And print square would be the same as print info. And that's all you're going to do with a print info. You're going to define a function. It's going to take self, okay? And then it's going to print things out. So if you look back about 15 minutes from where we are right now, you'll see that print square is very much like the print info that you need to do for this lab. Okay? And they just want to have you print it out in a specific format and use the model year, the purchase price, and the current value. So they give you current year here, and they're going to say model year is that, purchase price is that. They're going to calc the value, and then they want to print the info. Oh, and you have to declare the purchase price attribute. So here you have self.modelYear. You're also going to want to do a self.purchasePrice and set it equal to, let's say, 0. So you have to do that here. So you have to define a function called printInfo. You have to declare the purchase price attribute here. And then this will work. So those are the two things you have to do for that particular lab. And then here is the lab for winning team. And it says complete the team class implementation for the instance method getWinPercentage. The formula is team underscore wins divided by team wins plus team losses. So here, and then you have to, we have Ravens 13-3, where Ravens is a team, 13 is the number, 3 is the number of losses. Congratulations, teams. Ravens has the winning average. If the input is Angels 80 and 82, Team Angels has a losing average. So here all they want you to do is they want you to define a function called getWinPercentage. Now remember, this is an instance method, so you're going to have self, okay? And so you're going to have self in here. And then what you want to do is you just want to, you just want to use this calculation and return the value of the calculation. It says use floating point division, which is fine. So you're just going to return. You're not going to try and convert it to an int or anything like that. And then they've given you the rest of the code here. So all you have to do is define that instance function. Make sure you use self in those parentheses, and you should be fine. Modules. One last thing, and this is very, very powerful thing in Python. It's called a module. So a module is just a library of code. It's a library of Python code somebody else has written, and you get to use it. Now, you used modules when you did regular expressions. There are all kinds of modules that float all over the world. They range anywhere from, developing web-based interfaces with Django to, doing astrological or astronomy calculations, to math, to database. Python, if you're looking for a language that deals with a large number of different databases, Python is it. They have modules out there. They have code. They have libraries of code out there for all the major databases. If you're going to use, whether they be SQL databases or no SQL databases, they have libraries out there. You don't have to recreate the wheel. And that's really one of the powers of Python. huge open source community, huge commercial community, and you can go out and get modules for free. You get libraries of code that other people have written, lots of people have tested. You can get them for free. You can also go out and buy some. But that is where the a lot of the power of Python comes from. So that's all a module is. It's a file, a Python file, with a lot of code in it that somebody else has written, and you don't have to rewrite the wheel. You don't often have to redo things. You should always go out first and look at a third-party package, especially if it's free, and determine if there's something in there that you want to use. That is what we do, okay? Do not reinvent the wheel. 8.12 is talking about finding modules. Now, Python has a lot of built-in modules. Sys is a built-in module. RE is a built-in module for regular expressions. There are all kinds of built-in modules that Python already has. And if you have a question about what they do and where they are, you can go to python.org and click on documentation for the version, and you will get a massive amount of documentation. But there are also third-party ones, there's open source ones, there's all kinds of modules. How do you get that data in? Well, there's a couple different ways. First is the import keyword. You've used that before. Import, RE, imports the regular expression module. It imports all of the module. Now let's say I don't want to import the whole module. I only want to import a part of the module. If you use from, module name, import, and then give it names of methods or classes, you will only import a portion of that module into your code. Now that becomes important if you are importing lots of modules, because the size of your program, the amount of space your Python program takes up in the computer's memory, is directly dependent on the amount of code that it's reading in. So if Python only has to read in bits and pieces of the code, you're going to have a smaller footprint on the computer. Now for what we've done in this class, it's not really a big issue. If you're writing a true computer game in Python, if you're writing a large web service in Python, that is going to make a difference. So for what we've done in the class, it's not that important. If you are planning on going out and writing code in Python, writing a game in Python, then remember, from is your friend. From, module name, import, and then import only what you need is something that you're going to want to keep in mind. And executing modules as scripts. So basically, and I actually have used URL-lib. So if you import a module and you want to then use it, you just reference it. So it says import urllib.request, and then down here you say urllib.request.urlopenrec. So this does, it's saying I am going to request something from a web server. That's what this is doing. So I am going to send a message to a web server and get something back. And in this case, it's just they're searching from some fake zyBooks. So the important part here is I have this urllib.request. Is this urllib.request? So I'm saying from this module, urllib.request, do this function. And this function is URL open, passing in the rec. And then I set it equal to response. Response is just a variable. It's on the left-hand side of single equal sign. It gets back something from this URL open, and then I can read the information in and return it. So this is how you use what you have imported. And by the way, you can write your own. What this is showing you right here is sometimes you will find that there is a very good third-party module, but it's not exactly what you want, or you want only to use a portion of it in a specific way. So you can import a module, you can write your own module, and then you can use that module later. Now, why would you want to do that? You would want to do that because sometimes you're building your own set of libraries. I work for a company, we have several different products, and some of those products use common code. Some of our product uses very different code some of the time. So for the common code, they oftentimes will use, and this is lower level operating system stuff, but they will use other third parties. We will build our stuff on top of some of the third party stuff and then make it available internally in the company. So you may use a library to create your own library. And that's just what they're showing here. Packages. You can import a single module. You can import a bunch of modules. You can, and that's just called a package. And it's just a directory that has a lot of modules in it. So you might want to put like modules into a directory and then just import that directory. And that's kind of the opposite of from. From said, cut it down, only import exactly what I need. The importing a package says, I'm going to import all of this stuff. And they're both valid use cases. And you can import a directory structure if you want. So standard library. We'll be done here in a minute. So Python has a series of modules that are called its standard library, and they contain a lot of stuff. And here is a description of some of the stuff in their standard library. This is nowhere near all of it, though. Again, go to python.org, go to the documentation, you will get a good idea of what they have in their standard library, and it's a huge amount of stuff. NumPy, what in the world? Oh, this is just an example of a module, and what they're doing is they're saying import NumPy as NP. So maybe I don't want to type NumPy, N-U-M-P-Y, all over the place. I can give it a name, NP, and then reference it as NP anywhere in my Python script. So that's what that one is. And everything else is optional. Does anybody have any questions? I'm going to take that as a no. And this will be posted most likely tomorrow. And again, congratulations. Great work, everybody. And I will talk to you guys later. I'm going to stop.